Hi Doubles, so I'm just doing a little video on the question we were doing earlier. I didn't quite have time to finish it in the lesson. I had a little look on Solution Bank to see the approach that they took, and it's exactly the same as the approach that was taken in the lesson, because I do think the most obvious way of doing this is to use the compound angle formulae, as they do indeed here. Let's get a little bit closer so we can see it. I'm not just going to read this question out to you, by the way. I'm going to show you another way of doing it, which just occurred to me as I was eating my dinner. But okay, yeah. So this was the way I was doing it earlier. Write it out in compound angle formulae. They do nice and early on, respect to them here. Nice and early on, they say let C equal cos theta, let S equal sine theta. It just clears up your algebra, which can look really ugly. And then we start doing, essentially applying lots and lots and lots of hyperbolic trig identities until we've got it down all in terms of cosh. And then it's the same for cos 5 theta, lots and lots of trig identities. It takes a long time and it's a pain in the bottom, but eventually they get to the answer. Okay, let me just try and convince you, not convince you, but just show you another way of doing it. You might like it, you might not. Here's another way of looking at it. So let's take cos 3 theta first. I know that cos 3 theta can be written in exponential form as e to the 3 theta plus e to the minus 3 theta over 2. Now, as I want to write it in terms of cos theta, why don't I immediately write down cos theta, e to the theta plus e to the minus theta over 2, and then think, how am I going to turn that into cos 3 theta? How am I going to get the e to the 3 thetas involved? Sorry. Well, I'm going to have to cube it. Yeah, it's the only way I'm going to get e to the 3 theta involved. Now, the problem is, as you and I well know, when we multiply out those brackets, we're not just going to get e to the 3 theta plus e to the minus 3 theta. We're going to get some unwanted terms as well. Now, you'll like this method if you like binomial expansions. I like binomial expansions. They don't really worry me too much. Using Pascal's triangle, I mean, it's not too bad, yeah? So what I'm going to do is I'm going to cube that. Now I'm just going to do this over here. Hopefully you can see this. I can't remember exactly what the area was I set the window for. But if I try and multiply that out, I'm going to get e to the 3 theta plus 3e to the... Right, now this is going to be e to the 2 theta times e to the minus theta. Then I'm going to have 3e to the theta times e to the minus 2 theta, and then plus e to the minus 3 theta. Yeah? Now, great, we get two of the terms, which we wanted, but we want to take away these two and simplify them. So we need to take away minus 3e to the theta minus 3e to the minus theta. Now, that's lovely, actually, because that actually gives me the answer really very, very quickly. I'll show you what I mean. This, in the brackets, is simply 2 cos theta, because it hasn't been divided by 2 yet. So after I cube it, I'm going to get 8 cos cubed theta. And this here is simply minus 3 cos theta. Sorry, minus 3 times, it's not quite minus 3 cos theta. Be careful with the 2. It's minus 3 times 2 cos theta, because it's minus 3 times this. And that is 2 cos theta. And so that's going to be minus 6 cos theta over 2, and then it gives you 4 cos cubed theta minus 3 cos theta. You might like this approach, you might not. I mean, I think it's slightly quicker than what they've done up here. I mean, it doesn't take them too long to get to 4 cos cubed minus 3 cos, but I think it's probably slightly quicker, maybe. If you like it, great. If you don't, stick with their way of doing it. It's absolutely fine. Okay, then we've got cos 5 theta. I'm going to use exactly the same approach, and I think it's really with the higher power that it really comes into its own. But be careful. Cos 5 theta, cos, not to the power of 5 theta, but cos 5 theta. Well, that's obviously e to the 5 theta plus e to the minus 5 theta over 2. And just as before, I think, well, I'm going to have to introduce a cos theta, which is e to the theta plus e to the minus theta. But I'm going to put it to the power of 5 to get what I need. And then I'm going to subtract what I don't need, basically. Now, if you think about the binomial expansion there, you're going to get, if I just quickly, maybe I could do this in a little bubble, in a little colourful bubble. um, somewhere nearby, just underneath. Okay, e, if I just quickly expand that, I'm going to get e to the 5 theta plus 5 e to the 4 theta times e to the minus theta, which is e to the 3 theta, plus 10, because I'm using 1, 5, 10, 10, 5, 1 here, it's going to be 10 e to the theta. And then the next few terms are just going to be the same because it's symmetrical, but with minus thetas. So it gives us this term and this term, which we want, but then we need to subtract the other terms. So we're going to have to take away 5 e to the 3 theta. So messy tonight. Plus e to the minus 3 theta. And we're going to have to take away 10 times e to the theta plus e to the minus theta. Brilliant. Okay, let me rub out my little, quick binomial expansion there. So if you like binomial expansions, maybe this method is for you. If you don't like them, this method is definitely not for you. Okay, so we've done that. And now we can actually, more or less, we're not far from writing down the answer. This is 2 cosh theta to the power of 5. So that's going to be 32 cosh to the power of 5 theta. This is 2 cosh 3 theta. So that's going to be minus 10 cosh 3 theta. I'm a bit disappointed with the cosh 3 theta there. And this is going to be 20, oh, not plus, minus 20 cosh theta. And that's because that's 2 cosh theta, yeah? All over 2. Now you can see it's only cosh 3 theta, which is a problem, but I can use this result in there, yeah? Because that is cosh 3 theta, remember? That equals cosh 3 theta. So let's use it. What are we going to get? We're going to get same first term, so let's just write it down again. And then we're going to get minus 10 times 4, which is minus 40 cosh cubed theta. Let me just scroll up and show you what I'm doing here. That's where I'm getting it from. That is actually 4 cosh cubed theta. So I'm multiplying all of that by 10. And then I'm going to get minus 30 cosh theta. Oh, it's actually going to be a plus. Sorry, I've just noticed that because it's actually minus 10 times minus 3, so plus 30 cosh theta. Watch out for the sign errors. Minus 20 cosh theta all over 2. And finally, we can write down the answer now. And I just think it's maybe slightly quicker. I don't know. Maybe not. Maybe we're better off just sticking to the old ways. But I just like new ways of doing things sometimes. So we get minus 20 cosh cubed theta there. Combine those, you're going to get 10. But divide it by 2, you're going to get 5 cosh theta. And if you look at the way I've done it, I would argue that's slightly easier than what they've done there. And I've got the same answer at the end, 16 cosh to 5 theta minus 20 cosh cubed theta plus 5 cosh theta. The last part of this question isn't really very bad. We're just going to literally use the results that we had before to simplify. We're going to let, maybe it would be handier if I could actually get a copy of the question. Have I got a copy of the question here? Is that it? Yeah, okay, yeah. Hence determine the real roots of that equation. Well, that is really similar to what the result I just had. It's got lots of similarities there, hasn't it? We already know actually what cosh 5x is in terms of cosh x. We already know what cosh 3x is in terms of cosh x. So it makes sense to turn it into a quintic polynomial, which is what we're going to do. So combining the results, we're going to get, where are we? we're going to get that quintic polynomial there. I don't consider this last bit very interesting. I'll just quickly discuss it. You get that quintic polynomial after substituting in for cos 5x and cos 3x, our previous results in A. Simplify it, you get a lovely simplification, and then you get cos x is therefore 3 over 2. So to find x, we need to rcos it, and we get plus or minus 0.96. Remember, you do get the positive or negative of rcos, even though the ln, it's not obvious necessarily from the ln result. Okay, I hope that was useful. And yeah, keep up the hard work and do get in touch if you are stuck with anything. Bye bye.